Welcome to the DBS Technologies AI and Machine Learning series, where you learn the future of intelligent technology. This series is organized by DBS Technologies, majorly for our Python and AI interns. So we decided to also open the opportunity up to our members in the general DBS Tech community, and also for anyone that is interested and decided to register or reserve a spot using our website on training.dbstechnologies.com.ng. So this is the first video of the series where we'll be diving into the series. So this series we are going to have like minimum of four sections. This first section is recorded, while some other sections might be live sections, while we also have the recording of those sections released on our YouTube page, where you can check them out. So what this series aims to cover is majorly to help people, beginners or people that want to get into more practical when it comes to AI and ML, to have better understanding, to help them understand the modern AI technologies we have, how are they applied in the real world. So this program or this series is designed for either a student, a beginner, even a developer, or anyone that is a tech enthusiast. So it will help us to build a strong foundation in AI and machine learning. So the first section, we're going into the introduction to data science, AI, and machine learning. So we'll also talk on the data science life cycle. The key skills needed for this section is just for you to understand what data science is. Here we are talking about AI and machine learning. How is it related to data science? How is data science coming into play? And when we talk about data science, how the life cycle is. So the section 2 is where we go into AI versus machine learning and versus deep learning. Yeah, these are three terms that most people use interchangeably. Yeah, they are related, but they are still a little bit different. When we get into section 2, we will distinguish between them, and we'll also go into the types of machine learning that we have, which is the major ones: supervised, unsupervised, and reinforcement. We'll talk about them, how to determine the type you are using based on your project, or based on the problem you have. Yeah. So the section 3 will go into the data collection and preparation, exploratory data analysis, that is CDA, the data processing. And I believe we are in the level 2 of our Python and AI internships. Our interns, they've done this part, which is the exploratory data analysis. Yeah, so what we just have to do is we'll take it a bit further when that comes to sourcing for the data, getting the data, how you prepare the data, then process the data. So we just have to take it a little bit further by collecting, cleaning, and normalizing your data. So with section 4, we'll go into the machine learning workflow. We also have the Python for AI and machine learning. That is the common programming languages for AI and machine learning. We will also go into the model training and evaluation. How do we train our model? How do we evaluate it? We'll be going into it, the libraries to use, the life cycle, the workflow. Yeah. So after the first section, then we can now dive. That's why we said minimum of 4 sections. So the project and practicals can take like a section, 2 sections or more. Depends on how we have more problems to work on. So this is where we'll be diving into the real-world AI applications. We'll be having hands-on projects. We'll be doing some little projects on AI and machine learning, and also we'll be giving an intro into deep learning for those that might want to go or take it a step further into deep learning. So I want to welcome us once again to this series. We'll be going straight into the first session. Yeah, the first session is Introduction to Data Science and the data science life cycle. I've been hearing about data analysis, data science, if you are common with that. And for some of us, we don't even know the difference. All we are just saying is data, data, data. So what is data science? When you hear about data science, what does data science mean? So data, when you are talking about data science, we have the data aspect. So you first need to know what data is. So data is just information that consists of facts and figures. It consists of facts and figures. In computer, when we are doing computer studies in school, then we say data is a raw fact that has not been processed, or yeah, I think I'm right, that data. So now when we are not saying data, so in terms of data science or data analysis, these are facts and figures. So the information that just has facts and figures. So data science is not the combination of multiple disciplines. Data science combines multiple disciplines. When we are talking about fact or figures, we have a discipline that focus on that, which is like the statistics, where they work on data, figures, data, to make inferences for them to the relationship. They do some calculations, some permutations and combinations on them. Statistics, mathematics, they work with figures. So then we have another discipline, which is the computer science. This is where bringing the computer knowledge, the programming language, and some other things, bringing them into what? Into mathematics and the statistics. And we also have the domain knowledge. Yeah, domain knowledge, because based on the data we are analyzing or we want to get insights from, we need a domain knowledge. If you are working with a medical data, you need to understand how medical data works. You need to understand how the relationship is and some other things. So if you are working with maybe financial data, you need to understand how the finance works, the economy, and some other things. So we also need domain knowledge. So data science is a combination of multiple disciplines: mathematics, statistics, computer science, and domain knowledge to analyze data. We need to analyze data, and we do what? We extract knowledge and insights from it. So that is similar to what data analysis also does. So data science then also takes it a step further. Then after doing all of that, we do what? We build models. Yeah, it involves building models also. So based on the data we've analyzed to extract knowledge and insight, models that can predict maybe the next thing to happen, or models that can assist in helping us extract knowledge or insights from things. So that is data science. So data science involves data gathering, collecting relevant data from various sources. We also have data analysis, yeah, because there is no way you'll be into data science, you won't still know about data analysis. Yeah, you still need, because when we are talking, before you go to building your models, having maybe your machine learning models and the rest, you need data. And when you are needing data, that is where you still need to explore your data to understand your data. Because if you don't understand your data, you can't build a good model for your work. You can't build it, and you won't be able to properly evaluate your model if it's performing well or not, because what you didn't understand the data you are working with. So that is why data analysis comes in place. You interpret that data to find patterns and trend. While doing that, is in the course of doing that, you might also discover that maybe some data are not properly cleaned, are not you need to make some adjustments, some modifications to the data. It is during the stage of data analysis you do all that. And you also have the decision making, where you make what you use those insights for informed or data driven decisions. So I mentioned the 4 disciplines of data science, which is mathematics. So it involves the statistics, probability, and linear algebra. Yeah, statistics is also can be put as a sub-discipline of what? Mathematics. So we have the computer science. This involves the programming, the algorithms you use to work on those data, the data structures. This is where computer science comes in place. Also, we have the statistics and machine learning, where you model, inference, and prediction. Yeah, that I said, apart from you are in data analysis, you just stay in the part of interpreting the data, you find patterns and trends. Sometimes you also make decisions. Yeah, but now when it comes to data science, you model, you create inference, and you also predict. You create a model that can predict. So you have domain knowledge. This involves understanding the specific industry or problem. So when we now talk about the real world framing now, data science, comparing it to the real world, data science powers decisions in companies. Yeah, like Flutterwave used for payments, it can be used to do what? To detect fraud. Maybe a fraudulent payment, or detecting when some unauthorized person is using your account to make payments. So data science are used in companies, even in Jumia. Maybe when we have product recommendations, you see that once you buy a particular product, or once you just search about a particular product, the next time you are going on that app, you start seeing recommendations, or people that bought this usually buy this together with this product. That is product recommendations. So that is product recommendation. And the Nigerian government, it has when in terms of maybe public health analytics, they want to get some information about the public health, releasing figures or some information out. So in the real world, we see data science being applied every day. Example, even all these e-commerce websites, when we have customers shunning, maybe because some customers after some time they will leave, what could cause them to leave? Even in the banking sector, or fintech, where data science is being used to power decisions. Sometimes you see them giving you access to loans or some credits. Why sometimes you won't be given access? How do they make those decisions? They are all based on what? On data. Even when we go to our social media pages, we talk about the algorithm. When we see some ads, we'll be like, how do they know you need this? Or we see targeted ads. Data are being used for all that, even in news recommendation. So data science is at work each and every day. It's at work. So then we move into the other part of this section one, which talks about the data science project life cycle. So the data science life cycle is just the systematic approach to extracting insights from data. It guides the data scientist from problem definition. You need to first understand your problem. What are you trying to solve? Then to model development, and then evaluation. So what is the problem? After you've understood the problem, you go through some processes, some steps. Then you get to model development. That is, you've created a model, you deploy the model. Then you also need to evaluate your model. Is it performing very well? So then it also provides, data science project lifecycle also provides a structured framework for managing data projects. Anytime you have product, it's just you can follow the framework. It's a structured framework that you can use to manage your projects rather. So, and it ensures thorough analysis and effective communication of results. So what are the stages? We have the problem definition, which is the first thing. What you do here is you clearly define your problem. What are you trying to solve? What is the question you are trying to solve? Understand the business context. What is the context? Because context also matters. And you outline what, after you've understand the business context, what are your objectives? What are you trying to achieve? So this is the objective. Then what are the deliverables? When you know your objective, what are the deliverables? What do you need to deliver? What are the products you need to give in the end? The results you need to produce in the end. So an example is predicting loan default risks to minimize financial losses and improve lending decision. You want to predict loan default risk, that if you borrow people loan, will they pay or not? How long will it take them to pay? Will they default based on the agreement? And why do you need to do this? You need to minimize financial losses for the bank, because once a customer defaults on his or her loan, the banks begin to make financial losses. And also, what do they need? What is the objective in order to improve their lending decisions? So you need to understand the problem, clearly define the problem. So the second stage involves data mining. This is where you now need to identify the data source. Where do you get data? Oh, for example, we are talking about the loan default risks as a fintech example now. So you source for your data through databases, the bank itself, or the fintech you are working on. If they've been existing for a while, they have some data. So you can go through their databases. You can get them through APIs. There are some platforms that what they just do, they provide data for you. You can just get data from there. Maybe you buy it or you subscribe, you get data from them through web scraping. Just you can scrape the web. You just write some scripts, then you scrape information or data from the web. Though there is an ethical part to this web scraping. Yes, it can be done, but it has limit and it has some type of data that you can scrape without getting into issue. And also during your data mining, you need to also ensure quality. What is the quality of those data you are getting? And what is the compliance? Compliance with the standards, the regulations, and all of that. So you need to identify your data sources. So example is collecting customer financial data. In the case of our loan default risks, we want to improve lending decision. So we need to know the customer financial data. We collect their financial data, maybe from the type of transactions they make, what is their credit scores, the previous loans they've collected, how did they perform, and the loans, how did they perform. We collect all this data. Then the third stage involves the data processing. You've collected your data, but even though you've collected your data, some data might not be accurate. Even those that are accurate, some might have missing data. Yeah, permit me to use that word, missing data, where you have for some customer, you're able to get all their details. While for some, you can get some details, maybe their credit score, their transaction, but you can't get some other information. So you need to clean your data by removing errors. While for some, we have duplicates, a lot of errors will be there in the process of you mining data. This is where you now clean your data. You clean your data, you take it to you put it in a structured format, you remove errors and outliers. What do you mean by outliers? Maybe when you collect data, almost every of your data is falling within a particular range. Then you just have maybe one or two data going to the extreme end. Sometimes even that's why you need to understand your problem. Because when you understand your problem, you understand the business context. Now, for example, when you want to gather data about age, we have people, most times maybe when we read Bible or stuff that we have, you can see that people's age, you have now 100 and something. But now, looking at the present time, you have the age. Now, if you are gathering data of ages, now you have age, even maybe the longest, the oldest person living on earth will be around 100 and something. I'm not saying, I don't know the exact age, 100 plus or so. But imagine you gathering data, and when you are gathering their ages also, because you might also need the age, because their age might also affect. Maybe these people are more older, they handle money very well. These people are more younger. You can also need it. While gathering data, you are seeing an age that is showing you maybe someone is 900 plus or 800 plus. Because you understand the context and some other things, you know this is an outlier. Then what do? You remove the outliers. That's why I said you also need to understand the context. Because in some cases, the outliers might actually be true, while for some, it might be a mistake or errors. So you remove errors, outliers, because that outliers will affect your results. Because imagine everybody's age between maybe 18 to 90, and you're having someone in 800, and by the time you want to create a model, for example, if you are using a linear regression mode, or just you want to create, it will have an effect. Just imagine, let's just take the basic statistics. We have the median and mean. Let's say you want to take an average of the age, and you're having maybe the average of 4 ages we have 20, 20, 25, and you have the last one to be 800. If you are to take the average of that age, the age normally, because we're having 20, 20, 25, the average should be around 20 something, right? But because of the last person who is an outlier that is having 800, that age is 800, your average will not fall in between 20. You'll be having an average of maybe more than around maybe 400 or something like that. I'm not saying, I'm not calculating that. So that is to tell you outliers can affect your results. So that is one of the reasons why you also need to clean your data. You will also transform it for modeling. I said you will need to process your data into a structured format where you need to normalization. For example, in maybe when it comes to what to, this might not be related to the fintech example we are doing, but just giving a general example. When you want to take the, okay, even let's use the age. When you want to take the age, age is calculated in years. Now, why for someone can decide to put his own age in days. You can convert years to age. Years to days rather. So because this person's age is in days and that person's own is in years, somebody's own age can decide to put his own in his months. You need to all normalize them to the same the same units, for example. Or maybe we have weight, somebody is putting kg, somebody is putting lb and all that. So you need to normalize them. And even when you normalize them, or you can convert them, you can convert them from one form to another. Or you can decide to normalize, okay, when you have the maximum, when you have in this scale, the maximum should be from this, maybe 0, that the minimum should be from 0, the maximum should be 20. You can normalize, or no matter their age or everything, you can normalize that age, no matter the value, into that scale. So you also have encoding. So this an example in the fintech example we are solving is you undo missing credit history. Some people might have credit and missing credit history. So you can undo it whether you apply mode, you apply the mean, the median. So you remove duplicates. Where you have duplicates, you remove it. You encode the employment status. And you encode them. Maybe when you are having employed, unemployed, you can encode it. Okay, somebody that is unemployed, maybe you can give them a value of 1, unemployed is 0, self-employed 2, just something like that. You encode it. So we also have the exploratory data analysis. This goes hand in hand with the data processing, because while you're also processing your data, you need to visualize it. When you've processed your data, you visualize your data, you identify trends. Even from there, you'll be able to predict anomalies. Oh, this thing is different, it's going off. So you visualize, you identify trends. What is the correlation? We have different type of graphs and plots we can use for that. And each of the plots has what they can do. So there is a video, one of the internship section on EDA. Maybe if you need that, you can reach out to us. Just reach out to us. We will give access to because it's for the interns. The access is not, the video is not listed as public. Yeah, it's not listed. It's a private video. So you can give you access to that video. So you'll be able to watch, to understand where we need, or even the slide on it, to understand the different chart or plots you use for different what to identify different trends and correlations. Yeah. So here you analyze the default rate trend by demographics, maybe by income, by loan, or the loan amount they are collecting. So you explore your data, you create visualizations. So while we have stage 5, which involves the reporting and the future engineering. Reporting and future engineering. This involves the future selection and engineering. So now for our problem, what are the particular thing you need? The future you need to select. What are the part the future you don't need? Maybe for example, I gave an example of age. You might decide that, when you explore your data, you see that, oh, does age have effect? If age is not having effect on your data also, you can decide to drop it. Or maybe their location. If the location is having effect, you select it. Oh, this is having effect on you. So this is where you select the feature, and you do feature selection and what, and engineering. So you identify the relevant features. Which features are relevant? Which one are redundant? And also, if there is a need for you to create new features, you can do that. You create new features. Then when you are creating new features, the data for the features, you can either get it, you go through data mining again, or you can derive that new features maybe from some values. And also in this part of feature selection, because there are some features now that if you select them, automatically they've given you, when you are building a model, they've given your model the answers. It's called a data leakage. Because on its own, the models where you are creating and you are using some algorithm, they are smart. On its own, they will just look at, they know a particular feature that will automatically is given, they can pick it and just start producing good results. By the time you evaluate it, you'll be like your model is perfect. But in the real world, it will start failing. So it's in the feature selection that you detect all that, and you remove those kind of what features. Because by the time you start building your model, those features will have effects on it. By the time you have a model you want to calculate, maybe, and you are using linear regression, it's even more easy now. It's because you call regression normally in statistics or mathematics, you can do without even building all this model. You can calculate regression. So you just giving it some features, it can do some calculations on its own, and it gets what it needs, and it produces a perfect answer. That is where data leakage has come in place. So now for fintech example, you can create new features like what, debt to income ratio. You didn't have that initially, but you can then, maybe your data mining, you didn't have that, so you now be the one. So from maybe the income the person is collecting, then from the amount the person is owing, you create a new feature, a new column, where what will be there is debt to income ratio, and you calculate there. Credit utilization, average transaction value. This is where you select relevant features and create new ones or remove unnecessary ones. So after you are done with all this basic stage, then you now move a stage further, where you go into the model building. Most people, that is the reason, you can see the reason why we need to talk about what is data science and how it is important. Because if we are talking about machine learning, we just talk about we are building models, we are evaluating models, and we deploy. But before you get to the stage of building models, you need to do a lot of things. You can see we have like 5 stages before even building models. So you need to understand your data. Some just jump, even they will just have they won't clearly understand the problem. They won't clearly define the problem. They will just have little understanding of the problem. Because if you don't even know the problem at all, you won't be able to build a model. So that's why I said they will have little understanding. They might not have the whole understanding, a deeper understanding of the problem. Then they just jump to what? The model building. And when they get to model building, they will discover they need data. So because they need data, they can just go and just get a data that is not of good quality, or they decide to even generate the data and use. So model building, this is where you choose your modeling techniques. Is it regression you are using? Is it classification? The reason I don't want to mention the types now, like when we talk about the supervised, unsupervised, and reinforcement, we have not got into that section. That's why I'm not talking about it here. Because it's under, if you first know, is your work going to be supervised, unsupervised, or reinforcement? Is when you know that first, then you know, under supervised learning, we have regression, we have this, we have, so, but in the simple format, you can see what is the modeling techniques we are using. Regression. This regression now, maybe the price of house, you want to predict the price of house in the next 4 years. In that one, you take past records, so you predict. That is where regression comes in place. You are predicting a value or all that. For classification, maybe you want to classify this image into this, or you want to classify this data into a particular category. That is where your classification comes in place. So is in model building, you also train your model on the training data. The data you have, you are going to split it into 2 or 3, into the training data and the test data. While sometimes we also have the training data, you validate, then you have your test data. We can have 3 or we can have 2. But this you use all your data at once, because you know it's not easy to get data. And by the time you use all your data at once, how will you test or evaluate your data, your model? You won't have any data. And when you use the data that you used to train your model to evaluate it, or you won't know the true state of your model. So that's why we split our data. You keep some parts, you use some parts to train. It can be in whatever ratio you want, 30, 70, 30, 80, 20. It depends on the amount of data you have. Yeah, because it will train your model too. You also need enough data. Why you also need enough data too, you should know that you also need some data to also test. So you can also have maybe 70, 10, 20. When you train on, 70, 20, 10. You train on 70%. You validate maybe with 20%, then you test with the remaining 10%. You can do that. It depends on how you want it. So here, for example, now for our work, you can try to develop a random forest classifier. So when we are talking about classifier, then you'll be like, oh, this person will default or not. So that is what classifier means. I'm not talking about the random forest part now. So we are classifying. You are classifying and each maybe client or customers into, are they defaulting or are they not going to default? So now, and one of the things that the reason why you also need to process your data, to explore your data, is to, when you said you analyze the default trends and demographics, because there is this thing we call, when we are building model, we need to avoid bias. Now imagine you building a model that predicts a loan default rate or the probability now, and we are using it because there have been cases. So some set of people, you see them getting loans, while some people you see them not getting loans. Why sometimes the people not getting loans now, it might be automatic because we have individual differences also. So some people, because of the data they have, the model predicted that they will default. Meanwhile, they won't really default. So we can see some bias. So it might be the reason why, or you see some specific people from a race, maybe the black people, when they apply based on their country or their location, they are being denied loans. Why for the whites they are being given loans, all that. So this might be based on what? On the data that has been used to train them. The data is what is biased. There is no fairness in the data. So that's why you need to check your data. Okay, is all the genders well represented? The female and the male, are they well represented? The white and the black, are they well represented? The children, the youth, because I don't want to use children now, like the youth, and also the senior citizen and all of that. You need to ensure your data is balanced, because if your data is not balanced, if you are not careful, yes, you use it to train it. By the time you deploy the model, you will discover that your model will become what? Biased. All these are what you need to understand. So that is the essence why we need to go through all those process of data preparation and data processing. So model evaluation. So after you build your model, you evaluate your model. You evaluate using maybe using accuracy. Yeah, how accurate is the model? Precision and recall. You evaluate it using that. You can also compare multiple models. Even normally the best way is when you even use multiple models. You use different type of models. Then when you are done with the model, you compare them together to know which model performs well on your data. Some model will perform well on this data. Meanwhile, because that model is performing well, if you use them on some other type of data, they won't perform very well. So you need to select what the best performing ones. So all of them comes in what? In terms of model evaluation. So here now, we can access our model. We use accuracy, precision, and recall. So then the next stage after you evaluate, you've seen that, oh, this model is performing very well, it's good. Then you can now deploy. So when we talk about deployment, we integrate the model we've created into what existing systems. So we have a system already existing, then we integrate the model into it. Just like the way we have most of our softwares or applications nowadays, you can see everything is having AI included. Even apps or software that don't have AI, even websites that you see AI in almost everything now. Yeah, they are trying to follow the trend. So, but even before they come to the place of that AI, the AI has a model. So the model is not being integrated. The AI model is being integrated into an existing what system. So example, now even here you can see Ask AI Assistant, even in my PDF reader. That is just an example. You can see all these ones, the AI features. Listen to podcasts, even though it's pro, and some of those things started including AI in them. So you integrate the model into an existing system. Yeah, maybe the bank that want to use it to make decision, they already have the application. So they will integrate that model into the application. So anytime, that's why you see that loans now, it's faster to access loan even online. Just giving few of your details, they will tell you the amount of loan you can collect, or if not, you are not qualified. Before, you have to go through all the paperwork, all the process. You go to a bank or the institution offering you the credit facility. You submit a lot of paperwork and all that. It goes through a lot of physical selection and all that. So here now, you just integrate your model into the existing system and your model will do the work. Though there are some, that is why even while doing the work, we should not just leave the decision making just to the model alone. There should be, if they can do it, the model can be making the decision. Then when it comes to a time, there should be a time that they will do some reviews on the performance of the model. Or people it has declined, why did it decline them and all that. The people it are provided, they need to understand. So if they know the model is performing well, and if it's not performing well, they can take it back and work on it again. And also in some cases, the model can suggest to the people that has the existing system, can suggest to them, then they will still be the one to make the final decision. But in that case now, why the model is suggesting is making the work of the people making the decision easier, because it has already pointed some things they might not see. That's what models can do. Some things we can't see, they will point it out for us. Some trends that you can't identify, they will point it out for you. Then you see them, you'll be like, this is the reason why. So is it a good reason, or should we still try and consider this person? So now in deployment, you integrate your model into existing system. You will continuously monitor the performance post deployment. This is what I mentioned, that it needs to, even though you've put your model into an existing system, you need to keep monitoring it every time so that it won't start promoting bias. So you integrate your predictive model now in terms of our loan. You integrate it into what? Into a loan approval system for automated risk assessment. I think in our practical section, this loan predictive default, when you're like loan default model, we will try and build it, we try and work on it. It will be one of the projects we'll work on. So the takeaway now, the data lifecycle provides a structured approach to solving a complex problem. So if you have a complex problem you want, just follow this data lifecycle. You take it stage by stage. Then each stage is critical. You can see that I explained what each stage does. It's critical to ensure that your insights are high quality. And you can only get high quality insights from high quality data when you have good data. And when you have high quality insights, you are able to make good business decisions. So in the real world, you often move back and forth between stages. I mentioned this, you move back and forth between stages. For example, returning to the data processing after the exploratory and descriptive analysis. Explorative and data and descriptive analysis and reviews new issue. I mentioned this here, that the ED and the data processing, they go hand in hand. I think I mentioned it, because after you remove errors, you've done some things, you need to visualize it. When you visualize it, it might reveal some other anomalies. Then you need to go back to your data processing again and start working on it. Then when you proceed to the reporting or the future engineering stage, you see that, oh, you need to drop some redundancy, you need to create new features. In times after you've created the new features, you can also go back to EDA to see, to visualize it. Or while creating a new feature, you'll be needing some information for that new features. You go back to data mining to collect data again. You can see, so you move back and forth between what? Between stages. So it's not saying that after you go through this, you can reach model building now, and your model, after model building, you evaluate. Your model is not performing very well. You try different multiple models, and they are still performing woefully. And why they are performing woefully, the reason why you notice that what is due to what? The data you gave it. So you go back to your data mining again, which is stage 2. Then you start getting it again. You start getting data again. You go back to your processing again. So you move back and forth between stages. So these are just self-check questions. So the assignment here, maybe for those that are registered, will communicate the assignment to them and they will do it. That is designing the rotation prediction life cycle. That will be later on the work on those assignments. But the self-check questions now. What are the 3 core activities of data science? The 3 core activities. All these stages, you can categorize them into 3 core activities. You gather data. After gathering your data, you analyze your data. That is where the data processing, the EDA comes in place, and the feature selection. Then the decision making. That is after you build your model. Yeah, you visualize, you've seen the results, you build your model and all that. So name the 7 stages of the data science life cycle in order. You have the problem definition, data mining, data processing, EDA, reporting. So the decision making, reporting also falls under decision making, model building, and all this. So reporting or feature engineering, the model building, model evaluation, and deployment. So, and in the fintech use case, what problem was being solved? In the example we are given in the section, the problem that is being solved is we want to predict the loan default risk so that we will minimize what? Financial losses, and also do what? Improve our lending decision. So this is where we'll be bringing an end to section 1. You'll see in section 2, the details of the section 2 will be communicated, whether it will be a live section or it will also be a recorded one. But whether it's live or a recorded one, be sure that the video will be available on our YouTube pages. You can do well to watch out for it. Thank you.